All right, ladies and gentlemen, last one for chapter 3. Starting with last time. So, find the limit. Remember, we're looking at these lead ones. If they're both just x's, it's going to be the number in front, which is 2 over 1, which is just 2. So, this lesson's putting it all together, everything that we've done throughout the entire chapter into one thing here. And really finding everything we need to know about graphs. So, guidelines to analyze the graph of a function. So first determine the domain and range of the function. Then you're going to find the intercepts, the asymptotes, and the symmetry of the graph. Locate the x values to which f first derivative of x and f second derivative of x are 0 or do not exist. And then use the results to determine the relative extreme endpoints of inflection. So, I have a little worksheet, not really a worksheet, but a stat sheet, a quick reference sheet, I guess, that kind of goes through and explains what to do for each step. So you'll have that when you're working on the homework here. But while we're going through the lesson, I'll kind of show you how it all fits together. So first thing that I do is I find the first derivative. Now, I'm going to distribute this in just so this is easier. To 2x squared minus 18 is our top. So derivative, we're going to have to do the quotient rule. So derivative of the top would be 4x times the derivative, or times the bottom of x squared minus 4. Before I get that far, minus derivative of the bottom, which would be 2x times 2x squared minus 18. Bottom is just squared, so x squared minus 4 squared. So when we put stuff together, 4x and x squared would be 4x cubed. 4x and 4 would be minus 16x. Negative 2x and 2x would be a minus 4x cubed. And negative 2x times 18 would be a plus 36x over x squared minus 4 squared. So, last step here. Negative 4x, positive 4x cancel. Negative 16x and a positive 36 make 20x over x squared minus 4 squared. So, first derivative done. Second derivative now. So derivative of the top would be 20 times the bottom of x squared minus 4 squared minus derivative of the bottom, which are times the top times the bottom square, or derivative of the bottom. So 2x squared minus 4 times 2x. This is all over the bottom squared, so x squared minus 4, and if it's squared already, it becomes to the fourth. So, you can get rid of one of these. So, 20x squared minus 80. 2x and 2 would be 4x times 20x would be minus 80x squared. All over x squared minus 4 to the third. So final answer here of 60 x squared negative 60 minus 80 over x squared minus 4 to the third. So that's been done. So now we're going to do x intercepts. So if I set this top equal to 0, I know this would go to, that was all in there, 2 times x plus 3x minus 3. So my intercepts are going to be -3 and 3. Y-intercept is if I put 0 in for x, I would get -18 over -4, which would ends up being 9/2. Next, I'm going to look for vertical asymptotes. Well, looking at the bottom, x squared minus 4 goes to x plus 2, x minus 2. Well, it doesn't cancel with anything on top. So my vertical asymptotes are -2 and 2. Horizontal asymptote. Well, if we go back up here, they're both x squareds, so it's what's in front. Well, the top has a 2, so we have horizontal asymptote at 2. Critical numbers. What would make this top be 0? Well, what would make 20x equals 0? Well, x would have to be 0. My possible points of inflection would be what would make this bottom be 0. Well, if you pull the negative out, you technically have 60x squared plus 80. Well, there's no way that ever can equal 0. So there's going to be none. Now, domain. Just something to think about. So domain is going to be all reals except what? Well, it's going to be whatever would make the bottom be 0, which is 2 and -2. Well, x cannot equal 2 and -2. As far as symmetry, so constants always count as evens. We have even exponents here, so everything's technically even. So it's going to have y-axis symmetry. So that goes back to, we did that, I believe it was the pre-chapter we talked about it, how to determine symmetry. So now we can set up our intervals here. So the first one, okay. So we're going to be covering all reals here, except for 3 things: our vertical asymptotes, our points of inflection, and our critical numbers. So vertical asymptotes are -2 and 2, and our critical number is 0. So we're going to break this up by these 3 things. So let me do it this way. So -2, 0, and 2. Actually, I don't want to do it that way, now that I think about it. Sorry about that. Here's how we're going to do this. We're going to set it up going sideways here. Actually, I take that back. We're going to use these. So we're going to go from -infinity to -2. We're going to need a -2. And then we're going to go from -2 to 0. We're going to need 0. And then we're going to go from 0 to 2. And we need 2. And then from 2 to infinity. So a test value we're going to do here is -3. Test value here is going to be -1, 1, and 3. So we're going to have f of x. We're going to have f prime of x, f double prime of x, and then our conclusions. I know, it's kind of messed up right now. I'll straighten it out on the next one. Started to run with it, then I was like, wait, nope, I don't want to do that. So yeah, but it'll be fine. We'll figure it out. So, have my intervals across the top, these across the sides. Now it's graphing calculator time, because this is going to save us a lot of time. So if we go to y equals, clear out whatever's there. So the first thing we're going to put in is our original, which would be, I'm going to do the parentheses 2x squared minus 18, close the parentheses. Divide. Now the entire bottom. X squared minus 4, close. So your y1 is your original function. Y2 is going to be your first derivative, which we ended up getting 20x on top divided by x squared minus 4 squared. Y3 is going to be your second derivative, which is negative 60x squared. Oh, I should put this all in parentheses here. So negative 60x squared minus 80, close parentheses, divided by, in double parentheses here, x squared minus 4, close them, raised to the third, close it. So now we can hit second table. So I'm going to delete what's all here. So now I'm going to put in test values and the points that we're testing, or possible inflection, critical numbers, vertical asymptotes, those are dividers. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So here's what we get, and I'm going to fill this in according to my calculator here. So the first thing, the only thing we need to worry about is what is at each one. So we have, if it's an error, that's undefined. So we're undefined. At 0, we get 4.5. And at 2, we're undefined. Now, we should here because those are vertical asymptotes. Then I'm going to go over to my y2. So next, I'm looking for signs. So we're negative, undefined, positive, 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 undefined, and then, wait, negative, undefined, negative, 0, and there I looked at the wrong one, positive, positive. Second derivative is my y3, which I'm going to have a negative, undefined, positive, 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 undefined, negative. So what does that mean? Well, if we're negative and negative, this means we are decreasing and down. This one is a vertical asymptote because we're undefined, which is what we want. Here we would be decreasing and up. So here then we are because it's positive and it was a 0, that means this is a min. And it's at the point 0, 4.5. So 0 being the x, 4.5 is what we get out of it, so 0, 4.5. Here would be increasing and up. Here would be increasing and down. So, and then our last one here is a vertical asymptote that I missed. So, even though we go from down to up, this isn't a point of inflection because it's a vertical asymptote. We don't cross vertical asymptotes, so it technically doesn't switch in the graph. Here, though, we go from decreasing to increasing, so that's a min, also with our second derivative test. Again, vertical asymptotes, even though it switches, not a point of inflection. All right, on to the next one. Let's see if we can make this better. So now we're going to do it for, oh, and I forgot. From here now we can draw this out, which I didn't really leave me a whole lot of room. But we know we have intercepts at -3 and 3. And we're crossing our y here at, say, 9/2, which I'm going to guess is somewhere around there. We have vertical asymptotes at -2 and 2. We have a critical number at 0, which is here. So by doing this here, we know we're decreasing and we're down. So we must be going something like that. Here, though, on this left side, so in this interval, we're increasing and we're curving up. In this interval, we're increasing and we're curving up. So coming down, coming back up. Here, we're going to be increasing and curving down. So we're coming up, curving that way. So this would be what the graph would look like. So based off of my intercepts and then how it's going here, that told me everything I need to know to draw this graph. So again, first derivative. So derivative of the top would go to 2x minus 2 times the bottom of x minus 2 minus the top of x squared minus 2x plus 4 times the root of the bottom, which was a -2, all over the bottom squared, x minus 2 squared. So FOIL the first part, which would be 2x squared minus 4x minus 2x plus 4. Here the negative and the plus would cancel, so I just got to distribute the 2, which would be plus 2x squared minus 4x and then plus 8. Oh, this would be a -2, this should be a 1. Ha. Okay, now I messed this all up, didn't I? Okay, so let me double check this here. So x squared would go to 2x, minus 2x would be -2 times the bottom. Okay, so we're good with that part. Here we have the top, x squared minus 2x plus 4. Bottom would just be 1, which means we would subtract. So minus x squared minus would become plus 2x, and this would be a -4. So the -4, the plus 4 cancels. The minus 2x and the plus 2x would cancel. And so we'd end up with 2x minus x squared is x squared, and then minus 4x. All over x minus 2 squared, which would be here. There we go. Now I'm back on track. Second derivative. So x squared would go to 2x minus 4 times the bottom of x minus 2 squared minus the top of x squared minus 4x. Derivative of the bottom would be 2x minus 2 times derivative of the inside, which would be 1. All over the bottom squared. X squared minus 2, which if it's already squared, become to the 4th. And then we can go through and cancel one of these. And then we'll FOIL this. So 2x and x, 2x squared. 2x minus 2 would be minus 4x. Minus 4x plus 8. Here, 1 times 2, so then distribute the 2 in would be a minus 2x squared, and then minus 8x, but that's minus, so plus 8x, all over x squared minus 2 cubed. So, plus 8x, minus 4 would be in minus 8x, so that'd cancel. Minus 2x squared plus 2x squared would be left with 8 over x squared minus 2 to the third. Okay. So, x-intercepts. So what would make that top be 0? Well, this could factor to x and x because it's a plus, both of them are in the middle, which would have to be minus. Which there's no way to get 4 factors of 4 added together to be negative 2, so there is no x-intercept. Y-intercept would be if we put 0 in here, we'd have 0, 0, 4, and a negative 2, which would cause this to be a negative 2. Vertical asymptote. Well, what would make this bottom be 0? Well, 2 would. So technically y equals 2. Horizontal asymptote. Well, top is bigger, so no horizontal. However, since there's not horizontal, we need to look at end behavior. So of this, we have x squared, but it's over an x, so the difference is only an x, so we're going to have an odd. So to the left, we're going to go down, the right, we're going to go up. And I know that's maybe a little confusing, but because it's x squared over x, there's only a difference of 1. So we're going to be doing one of those things. Now, critical numbers. So critical numbers are when we have the first derivative here set equal to 0. Well, we could pull an x out and we'd have x minus 4 left. So we'd get numbers of 0 and 4 for critical numbers. For possible points of inflection, we would look at our second derivative. What would make that be 0? Well, if that's an 8, there's no x on top. There's no way it could come 0. So there'd be none here. So, symmetry, before that domain, will be everything but makes the bottom 0, so all reals except x cannot equal 2. Symmetry, well, this one's even, but this one's odd. They either all have to be either or all have to be odd. So we're going to have none here for symmetry. So we're going to set up the graph the other way here now. So we're still looking at our critical numbers and our vertical asymptotes. So we're looking at 0, 2, and 4. So my first one is going to go from infinity to 0. And that's my 0. From 0 to 2. And that's my 2. From 2 to 4. And that's my 4. And then from 4 to infinity. So here's what I got set up so far. So my first one here is going to be f, and I need to put this high enough, f of x. And it's going to be f prime of x. And then we're f double prime of x. And the rest is conclusions. So, graphing calculator time. So I'm going to clear out what I have already in there. So first I'm going to put the top. So x squared minus 2x plus 4 divided by x minus 2. So y2 is my first derivative, which ended up being x squared minus 4x on the top divided by x minus 2 squared on the bottom. Y3 is going to be my second derivative, which is just 8 divided by x squared. Oh, it should just be x. Don't know where I was going with that. So it should be x minus 2 to the third. There we go. So now go to my table. I'm going to delete these all out. Don't hit clear or it won't do anything. So test value for my first one, I'm going to use -1. I use 1 and 3 and then 5. So in here I'm doing -1, 0, 1, 2, 3, 4, and then 5. So if I fill this in, first one's the only one I'm filling in are my 0, which I get a -2, my 2, which is undefined, and my 4, which is a 6. So then I'm going, okay, we're plus 0, negative, undefined, -0, plus. And then for second derivative, we are negative, 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 undefined, plus, plus, plus. So what does that mean? Well, the first one here, we are up, so increasing, there we go, increasing, and then down. Here we get a 0 and it's a negative, which means it's a max at 0, -2. Here we're decreasing and down. Here's our vertical asymptote. Here we're decreasing and up. Here we hit a 0, so we do a plus, which means we're a min at our 4, 6. And then we're increasing and up. So normally I like to write it this way just because it gives me more room. I can write it out. It's a little easier to work with. Now, if we do our graph. So we have no x-intercepts. We have a y-intercept here at -2. We have a vertical asymptote at 2. We have no horizontal asymptote, but our end behavior is we're going to be going down. So it's going to do one of these things. And then on this side, so if you think about it, we're increasing but curving down. And then we hit our max, and then we're decreasing but curving down. Over here, we're going to be decreasing but curving up and going back up here. Here at our 4, 6, so at our 2 points. And so our graph will look something like that. All right, so 3 more to go. Now, square roots can get a little tricky. But here's how this will work. So first derivative. So derivative of the top would be 1 times the bottom of, and I'm going to write this as x squared plus 2 to the 1/2 minus our top of x times our derivative of the bottom. Now the 1/2 would go in front, derivative, and then this. Now we subtract 1 from the half and make this a negative half. Times derivative of the inside, which would be to 2x. All over our x squared plus 2 to the 1/2. Okay. Now, as far as simplifying goes, if I have this to the 1/2 on the top, I can cancel that, and I just have a 1 minus. Back here, by canceling with the bottom, that really makes this to the negative first. And that'll weed itself out here in just a minute. Now, the 1/2 and the 2 cancel. And so we would have, let me see if I want to do it this way. I don't want to do it that way. Here's what I'm going to do instead. I'm going to times the top by x squared plus 2 to the 1/2. No, to the 1. What's that going to do? Oh, but the bottom is squared. So this becomes the whole. So yeah, it is to the 1/2. That's what I'm wanting to do. So that'll make this x squared plus 2, because the 1/2 power and the 1/2 power makes it a whole. And I'm really not making this exciting, and I'm really sorry. I really should. And in fact, I'm probably going to pause after this one to break it up, because it's going to turn into a really long video. Minus, here when we do it, to the 1/2 and the negative half, that cancels. So we have x and x, we have minus x squared. So the positive x squared and the minus x squared cancels, and we're left with 2 on top. Now, what we do to the top, we have to do to the bottom. So that makes this x squared plus 2 to the 3/2. So that'd be your first derivative. Second derivative is going to be just as fun. So derivative of the top goes to 0, which means when we times it by the bottom of x squared plus 2 to the 3/2, that's all going to be gone. So minus now the top of 2 times the derivative of the bottom, which would be 3/2 x squared plus 2 to the 1/2 times derivative of the inside, which is 2x. All over, if we square the bottom, this becomes x squared plus 2 to the 6/2. And I'm going to leave that like that for the moment for this specific reason. When we cancel this out, that's going to cancel one of those to make it 5/2. We can then cancel the 2 and the 2, and so we'd have 3 and 2x, and it's a minus, which results in, and I can just write it over here, I guess. So 2x times 3 would be 6, negative 6x, over x squared plus 2 to the 5/2. Okay. So x intercept would be what makes the top 0. Well, if our top was just an x, the top, well, would be 0. The y-intercept, if we put 0 in there, we'd get 0 over 2, which would be 0. vertical asymptotes, well, it's x squared plus 2, so there's no way to ever get 0. So no vertical asymptote. Horizontal. Well, here we would have x over x, technically since it's square root of x. So we would have the numbers in front, which would be plus or minus 1, with it being the square root on the bottom. Actually, I take that back. It should just be 1, I believe. Because if you have positive on top, positive on the bottom, x over x would be 1 over 1. Yeah. So, just thinking ahead of myself there. Critical numbers. What would cause the first derivative here to be 0? Well, if it's a 2, no way to get anything, so this would be a none. For points of inflection, negative 6x, well, if I set it equals 0 and divided by 6x, you'd get 0 here. So in this case, that's going to be my only one because there's no critical numbers and no vertical asymptotes, so I'm only going to have one break. So this one's a little nicer there on that note. Domain-wise, it's just going to be all reals. So all reals because there's no way to ever get a 0 on the bottom. We can put anything in here because it's x squared, so we don't have to worry about the negatives. Looking back up here at the original. And then symmetry. Well, we have x and x squared, so we have some of both. However, I gotta think a minute here. So my notes say symmetric with respect to the origin. And I gotta think a moment on how that goes with the square root, because technically that makes it singles, but we still have that constant there on the bottom. So we'd get the exact opposite out. Okay. So we'd have origin symmetry there. So when we split this up, we're going to go from negative infinity. I have room here. So negative infinity to 0, 0, and 0 to infinity. So f of x, f prime of x, f double prime of x. Conclusion. So, and I'll check this one on the graph and make sure. I think it's just 1 and not plus or minus 1, but I could be wrong there too. So, I'm going to pick, say, negative 1 and 1 for my two deals here. So when I put this in, so my original is x divided by, I can put this up here. So x divided by, and then parentheses, second square root of x squared plus 2, close the parentheses. Now I'm just going to check the graph here real quick. Oh, so we do. It is plus or minus 1. I was wrong there. My bad. So must be with the square root. So I'm not 100% sure. That's something I'm going to have to look up. And believe me or not, that does happen sometimes. So my next one, I have 2 on top. My bottom then is, and I'm going to use exponentials here, and maybe that's what I should have done on the original, but we'll have x squared plus 2 parentheses raised, and I'm going to put it alpha y equals a fraction here of 3 halves. So now on this one we have negative 6x divided by, and again we'll put the same thing in here of x squared plus 2 close them raised second, or alpha y equals, to get my fraction, of 5 halves. So now I'm going to go to graph. Second graph table, sorry. So I'm going to delete these all out. So we're negative 1, 0, and 1. So for the first one, the only one I have to worry about is the 0 here. So the next one, these are all positive. So they're all going to be increasing. And then we're positive, 0, negative. So what does that mean? Well, because this is a 0, number one, this isn't going to be a vertical or not or max or min, is what I'm trying to say. It's going to be a point of inflection. So we're increasing up, we're increasing down, and so here we're going to have a point of inflection at 0. So already kind of seen it. So the graph is going to come along, curve up, flatten out. Okay. And I'm going to pause here because this video is already 40 minutes. So we're going to pause this. So I'm going to stop it, and then I'll make a part 2 so that you can kind of watch this in a couple different parts, because I know it's going to be a lot. Like I said, it's already 40 minutes long. So again, if you need to go back through, rewatch something, remember to pause if you need to write stuff down. You can pan me, email me, send me a message on Google Classroom if you're having trouble. Otherwise, we'll talk to you here shortly in part 2.